Alright, HVACers, so this is a condenser fan motor out of a Train RTAA chiller. This motor is it's a 1-horse motor, so it's just a condenser fan. I ended up getting changed because the bearings are bad. Got a lot of side-to-side play. I don't know if you can see that or hear it. And then it even has some up-down. The up-down is not as dramatic, or the in-out is not as dramatic as the side-to-side. And for me, when I'm looking at fan motors like this, the in and out is definitely telling. But if I start seeing a lot of side-to-side play, I know that's when my bearings have the most damage to them. And so if there's just a very slight amount of in and out, depending on the motor and the type of equipment, I may let it slide. Now, if it gets really dramatic, or especially if I start getting any kind of side-to-side movement, I immediately know, okay, I've got a major problem here. I need to do something about it. So anyway, so we went ahead and changed this out as part of the PM. The customer had one on hand, but what I want to do today is kind of break this down. I've done this before on a smaller motor, and I wanted to do it on a little bit bigger one this time around. It's been a minute since I did the last one, and it was also when I was doing my lives back in the day. So I want to do a good detailed version of it this time, and try to do a little bit better format. Anyway, stay tuned. Okay, so like with any just typical motor, you've got 4 main bolts that hold the whole chassis together. Now, one thing that's unique about Train is they've got an actual plug that they use instead of being physically wired. Makes it really handy, makes it really quick in the field. You don't really have to worry about, as long as I've seen these burn out and blow up before, but as long as that doesn't happen, you can usually makes a really quick change out, and you don't have to worry about the wiring a whole lot. But the drawback is if it does ever fail, you've got to be able to get that plug to change it back out. So like I said, I've had these just completely melt the plugs before because they shorted out or whatever. And when that happens, you're looking at having to change that plug. So that can be a bit of a setback. But anyway, these are 5/16 on this side, 3/8 on this side. I've already got them all broke loose. Just got to finish taking them out. Okay, once we get the bolts out, we'll pop the end bells. This particular case is probably easier to start with the rear end bell, or the end of the housing. And one of the things I wanted to just make sure you understand is you're not going to get this end cap off of that shaft very easily. What you have to do is you'd have to clean this shaft up, and it'd probably be easier just to cut it off and then slide it out. Generally, what we typically do with these motors is we'll take them back to the shop, and then we'll stack them all up in a big scrap pile, and then take them and just sell them as just scrap at the scrap yard. Get whatever we get for them. So you can do that however you want. I know there are a lot of guys out there, I've even looked at it myself, that do that actually melt down everything in here and then try to sell it as that. You can get the winding out by just cutting it, and there's all kinds of methods of doing it, and there's a lot of really good material in here, but it just depends how much time you want to invest in it. So okay, there's the underside. That's going to be your thermal overload. The looks of it. Alright, I'm gonna see if I can get this back plate off of that bearing. It does not want to go. Alright, you can see where the bearing mounts in there. And these have what they call these there's a type of spring. It's like a, I forget the technical term off the top of my head, but anyway, this is just type of spring that helps push back against the bearing, help keep it seated. And so when the bearings get a lot of play around the around where they mount in, which means that the actual bearing housing is starting to spin and slip inside of its mount, that's when you start getting a lot of that in and out play. And that in and out play, you do have this spring, and there's a retainer spring that's pushing back against you, and so that's where you get some of that in and out movement from. So anyway, looking at these bearings, yeah, so you can tell this back one got a lot of play on it. Still got some decent feeling grease. Grease didn't feel that bad. These are a sealed bearing. I know they're sealed because they've got the seal in there. So you've got two types of bearings out there. You got sealed bearings and you have open bearings, or non-sealed. So these are called shields. And the inside here, behind this, is a ball bearing, which we'll open up here in a second. And both of these are sealed. So behind these shields is where the actual balls are. But what a lot of times you may buy bearings that they'll have shields on both sides, but they won't be actually sealed bearings. And so the purpose of that is, if you're ever doing a bearing job and you get that, you have to pull the shield off of whatever side you're going to be greasing from. So you want to leave the shields on one side. You don't want to pull them off of both. You just want to pull them off the side that your grease port's going to be pumping grease into it. So that's kind of some differences between shielded and non-shielded. I'm sorry, sealed and non-sealed, what I meant to say. Sealed bearings are greased from the factory. You know, when they're assembled, they're greased at that point with a special type of grease, and then it gets sealed inside of that bearing so that it can't get out. And it's literally sealed in there. It's hence the name. Anyway, so both, yeah. I don't know if you'll be able to see it, but I'm sitting here looking at it, and you can see the seams. And this one's got a lot of play. They're both very loose. In my experience, what I found is typically the fan side of the fan side bearing is usually the first one to start to go, unless there's some kind of special something significant happening. Usually you'll lose the fan side bearing, which is the near side, and then your backside or offside bearing, your rear bearing, will then start to fail because of the extra stress put on it by the fan side bearing, the near side. So that. You can see the windings inside of there. Big old stator for a regular motor, but they get a lot bigger than that. So, you know what I work on every day, you know, this is still pretty small. You know, we do bearing change outs. Now a motor like this is cheap enough. You're talking one of these motors is a few $100s, right? So this motor is cheap enough. It's worth purchasing a new motor than trying to actually change the bearings and try to fix it. Because honestly, that's the only thing wrong with this motor, is these bearings are wore out. If we had new bearings to put on there, this motor would probably run for a good while still. The windings themselves look really good. I did meg them with a megometer, and they megged really well. But you start getting into the 20 horse and up motors. We do, I mean, heck, I work on anything up to 300 horses, and you start talking big chillers. It is cheaper at that point, because you're talking motors at that level that are thousands of dollars. Even the big 300 horses, you're talking tens of thousands of dollars. Most of the time you don't buy those motors, you end up having them refurbished or rebuilt if they go out, or you're purchasing one from somewhere that's been refurbished already. And so those bearings on those things will be this big around. So that is when it becomes really worth for the customer to spend the time and money for us to just redo the bearings than try to replace the motor. Even on like a 20 horse motor, and here in Austin, you're talking, I think they're between $2,000 to $4,000, depending on the brand and what you go with. So even something like that, if we get the bearings for $100, usually not very expensive. Most of those bigger motors will have a bearing code on them, and so we can use that bearing code to reference what bearings we need to buy. We've got multiple industrial supply houses around that we can order bearings through, and so yeah, I mean, at that point they're looking at spending a few $100s for labor and material versus a few thousand, and have a good motor still. But you have to be really careful with that, because it does happen that if this bearing does the worst case scenario, which is that you actually start spinning on the shaft, then what it'll end up doing is it can wear that shaft down, and you won't have a good seat on the shaft. And sometimes it can be really hard to determine that, but that's one of the tests you want to do when you pull the end bells off. You want to spin these bearings and see if you can get any kind of play around the shaft itself, where the collar actually seats on the shaft. If you don't have any play right there, then you're probably okay. But if you start turning them and you see it spinning on the shaft, you probably don't want to do the bearings on that motor. That shaft is probably damaged. You're better off going ahead and purchasing a new motor. Just throwing that out there. So let's see if we can pull one of these shields off. We can see the bearings underneath. All right. So there's your bearing seal. Just a piece of rubber, really, nothing fancy. And there's your bearings. So all right. To get these off, they're going to require a puller. If you don't have any kind of pullers and you start getting into this heavier type of work, you're definitely going to want to invest in some. It's going to become a big part of your tools, is being able to pull things like bearings or sheaves, pulleys. Just depending on what you're working on, it becomes a big part of your tool chest. So I highly recommend getting something like that. Like I said, if you're just doing basic residential stuff, you're not really getting into too many big things, it's not as big of a deal to have some of that. I started off in residential myself, and then got an opportunity to get into some of the heavier commercial side and took it. So been there ever since. So if we were going to try to pull this stator, so if you don't know, this metal ring in here is the stator. It doesn't look like, so the bearings hadn't really started catching on the stator just yet. That's another big sign of failed bearings, is this whole stator will be, I mean the rotor would be very scarred up, and you'd look inside the stator and it'd be all tore up inside. And so a lot of times when you get motors that fail electrically, you always want to check the bearings first and see if the bearings are real loose, because more than likely, if they are, the motor failure was caused by the bearings at that point. Because what will happen is that rotor rubs on the inside of that stator, and eventually rubs it enough that it cuts through the insulation on one of those winding wires, and then it shorts the ground and blows the whole thing up at that point. So that's a typical failure that you'll see caused by bad bearings. If the bearings are still solid whenever you go to check it and it failed electrically, then yes, more than likely something electrically happened. But if you're needing to explain it to the customer of hey, this motor failed, well, why did it fail? Well, if you got loose bearings, you can tell them, well, your bearings went out, and you can give a lot more definitive answer other than it went bad. It's just what happens. I found, being able to explain things a little bit deeper like that goes a long way with the customer. Being able to build trust and them having confidence that you really, really understand what you're looking at. To pull this stator though, what we'd have to do is I'd come right here on this seam, and I'd cut this seam with a grinder, just straight down, split the housing open, and we could get to the stator. And what I've seen a lot of guys do, if you want to salvage one of these, is come in once you get the shroud off the housing. They come in with that grinder and then cut all the winding out off the top, and just cut it flush to the top of the stator. You can use a screwdriver or something and tap the rest of the stator through, and you got a big ball of copper there you can work with. Now these are coated in insulation, so you have to kind of melt all that off and melt it down, get it out of the way. But once it's all said and done, you've got a big ball of pure copper in your hands. And then the rest of this is straight steel. So this is steel housing. The rest of that stator is steel. This is going to be steel rotor. That may be, it looks like they may have inserted an aluminum core. I could be wrong on that. But anyway, so you got a lot of solid metal here. That feels like maybe cast iron. I don't think that's actual steel, but this housing is. So anyway, guys, hope you enjoyed it. Just kind of just a little more detail. Wanted to show you all the bearings and what can happen with these motors. Ways of salvaging them. If you have any questions, shoot them at me. Appreciate it.